So looking at the questions here, greatest coefficient of 1 plus x to the power of 14. So again, what we want to do is set up our r plus 1th term, which would be 14cr x to the power of r. It's pretty. This one's nice because there's one's going to make life a little bit easier in our question, in our expansion, and the rth term would be the one before it, which would be 14cr minus 1 x to the power of r minus 1. So when we're doing this one, we're going to drop off the x. We don't really care about the x for the greatest coefficient. We'd have it there if it was the greatest term, but for the greatest coefficient, we just get 14cr, ignoring that part, over the 14cr minus 1. Get an expression for that, so our 14 factorials would cancel. And then we start cancelling these ones. Remember, it's really the case we're going to have 1 over 14 minus r factorial times the r factorial times, and this part's going to be taking the reciprocal of it, so 15 minus r factorial r minus 1 factorial over 1. So the 14 minus r cancels with the 15 minus r factorial. So this is a 15 minus r because that's 1 more than that. 15 is 1 more than 14. R factorial cancels with the r minus 1. It's just going to leave us r. So that's where we get the 15 minus r over r. And then we get the same process. If it's going to be the greatest coefficient, where's the ratio greater than 1? So the ratio is greater than 1 when 15 minus r over r is greater than 1, or 15 minus r is greater than r, or 15 is greater than 2r, or r would be less than 15 on 2, which is 7.5. So it's greatest when r is equal to 7. So up to 7, that would be our greatest coefficient. So greatest coefficient then would just be the 14c7 because there was no other numbers. All the other numbers in the expression were 1. So that's going to be our greatest coefficient. Let's have a look at the next one. Greatest coefficient of this one. Now, this one, not too bad. It's got a 1 there. 2/3 is going to be a little bit of a hassle. So what do our expressions look like? The r plus 1th term would be 12cr, and the rth term would be 12cr minus 1. So our general term here would be the 1 to the power of 12 minus r, and 2/3 to the power of r. But again, we've dropped off the x, so it's just the coefficient there would be the power of r. So the 1 to the power of 13 minus r, and 2/3 to the power of r minus 1. Well, 1's cancelled. That's not going to do anything because the power of 1. And the 2/3 to the power of r divided by 2/3 to the power of r minus 1. So we've still got that. The other parts will cancel. The 12 factorial. This is the 12cr here. This is 12cr minus 1. And we're getting our cancellations. The 12 factorials. R factorial cancels with the r minus 1 factorial. And the 13 minus r factorial cancels to give us that. Now, if we're not sure about why 2/3 to the power of r divided by 2/3 to the power of r minus 1 will equal 2/3, well, here we go. We do the division, we subtract the powers. R minus r would be 0, and then minus times minus 1 would just give us 2/3 to the power of 1. So that's where the 2/3 come from. There, times 2/3 gives us 2 lots of 13 minus r over 3r when we do that expansion. So get that expression and see where our ratio is going to be greater than 1. So again, let's solve this one greater than 1. Multiply by 3r, and then the 26 will be greater than 5 on 3. 5r. And then do division by 5. R would be less than 5 and 1 6, which means r is equal to 5, which means it's going to be the 12c5, which is the 6th term. Remember, the 12c0 is the first term. So 12c1 would be the second term. So 12c5, and then so we get x to the power of 12 minus 7. 12 minus 5 gives us 7, and the 2/3 to the power of 5. Again, we're not putting the x in because it's just the greatest coefficient, and there's going to be our greatest coefficient. Another example, greatest coefficient in this example. This one's a little bit harder this time because there's much more going on because you've got a 3 and a 5 there. So you've got the tr plus 1 would be 9cr. 3 to the power of 9 minus r times 5 to the power of r. When we do that, there's 9cr. 3 to the power of 9 minus r, 5 to the power of r. The rth term would be 9cr minus 1, so that's that expression there. And then the 3 to the power of 10 minus r, 5 to the power of r minus 1. If you clean it up, your 9 factorials cancel, you're going to get the cancellation with the r factorial and the r minus 1. So that's why it's going to be the r on the bottom. Then 9 minus r minus 1, well, that comes 10 minus r. Cancels. We get the cancellation there. Then we get the 10 minus r on the bottom. Remember, this is being divided by this, so taking reciprocal. So 9 minus r minus and 3 minus 10 to the power of 10 minus r. So that's where that'd cancel and just leave you a 3 on the bottom. And 5 to the power of r, 5 to the power of r minus 1. It's going to give us just the 5 on the top. So that's where the 5 comes from. That's where the 3 comes from. There's our expression. Again, we're going to take the ratio, set it greater than 0, and then start to clean it up. So 50 minus 5r is equal to 3r. The 50 is greater than 8r, or r is less than 6 2/8. So r must be 6, because that was the first whole number less than 6 2/8. So the 7th term then would be 9c6, 3 to the power of 3, 5 to the power of 6. So there's our coefficient. You can get an expression there if you like. It's going to be pretty big once you start doing all those multiplications. It's quite fine to leave it like that. So that's still the greatest. It's still the greatest coefficient. So get that. We really need to go with that process. Be really careful and looking at this step, because that's where most errors are going to be made. Making sure we write it down properly, doing our cancelling properly, and getting these correct values in the correct spots that we need to get them.